Hello students, welcome to section 9. In this section, we'll be doing some examples related to completing the square method to solve quadratic equations. Now, this question is from page number 38, example number 1. I'll be taking one example from the solved examples so that you can see side by side in your textbooks for every step that we do. And we'll be taking one example from our problem set to which we don't have a solution, and we'll try to solve that question as well. Now, once you all are finished with this section, make sure you try some solved example by yourselves. For example, you can choose example number 2 from page number 39. That is an easy question, and that will help you in solving the in understanding the completing the square method. So we'll start with our example 1. We have 5x square minus 4x minus 3 is equals to 0. So always my first step is to divide the equation by the coefficient of the variable with degree 2. So in this case, my coefficient is 5. So I need to divide the equation by 5. So I'll divide the equation by 5. So that gives me 5x square divided by 5 minus 4x divided by 5 minus 3 divided by 5, which is equals to 0. 5 and 5 cancels out, so I am left with x square minus 4 by 5x minus 3 by 5 is equals to 0. Now before moving to our next step, we need to make sure we compare this to our standard equation for completing the square method, which is x square minus plus b by ax. This is not minus, it is plus b by ax plus c by a, which is equals to 0. So now we need to calculate the value of half into coefficient of x whole square. We have to find this value, and as we know that this value's coefficient is b by ax, which in this case is 4 divided by 5. So I'm going to find the value as 1 by 2 into 4 divided by 5 whole square. I can cancel this out, so I am left with 2 divided by 5 whole square, which is equals to 4 divided by 25. Now I'll be adding 4 by 25 to both the sides, of the equation. This will give me x square minus 4 by 5 x minus 3 by 5 plus 4 by 25, and this is equals to 4 divided by 25. Now moving to our next step, we have to make sure that the constant term moves to the right hand side. So we need to move minus 3 by 5 to the right hand side and let everything else be as it is there. So here we have x square minus 4 by 5x plus 4 divided by 25. This is equals to 4 divided by 25 plus 3 divided by 5. So now we need to compare this to one of the formulas, either a plus b whole square or a minus b whole square. As we know that a minus b whole square gives us a square plus b square minus 2ab. So as soon as I see a minus in my equation, that means I have to use a minus b whole square. So in this case, I'll be using, this is a square, this is minus 2ab, and this is plus b square. For now, I'm not solving the equation. I'm just trying to help you out to understand how to formulate the complete square on the left hand side. So that means a is equals to x and b is equals to 2 divided by 5. So once I get this, I can simply write a minus b whole square as x minus 2 divided by 5 whole square. So now my equation on the left hand side becomes x minus 2 divided by 5 whole square. If somebody has a doubt in whether this is correct or not, we'll just solve this on the left hand side. So x, we are going to solve this particular part so that we don't waste space. So this becomes x square plus 4 divided by 25 minus 2 into x into 2 divided by 5, which is equals to minus 4 by 5. So as we can see, these two equations are the same. So yes, our formulation is correct. So as I now have my left hand side, I have to make sure that my right hand side is also evaluated correctly. My right hand side has 4 divided by 25 plus 3 divided by 5. If I follow the LCM rule, I'll have 4 plus 3 into 5 divided by 25. So this implies x minus 2 divided by 5 whole square is equals to 19 divided by 25. Now I'll be taking square root of the equation. So this gives me x minus 2 by 5 is equals to plus minus under root 19, and under root 25 is equals to 5. So I don't need to write under root 25. I can directly write it as under root 5. So this implies x is equals to either plus under root 19 by 5 minus 2 divided by 5, or x is equals to minus under root 19 divided by 5 minus 2 divided by 5. Therefore, x is equals to under root 19 minus 2 divided by 5, or x is equals to minus under root 19 minus 2 divided by 5. So this is the solution for my question. These two for answers are the roots of my equation. Make sure all of you highlight your answers so that it's easy for the examiner who checks your paper to identify your solution. Now moving on, we'll be taking a question from our problem set so that we do not have a solution. So this problem is from page number 54, question number 7. So this is page 54, question number 7. This is sub question 4. So here we have m square plus 5m plus 5 is equals to 0. This is from problem set 2. So remember, we need to divide the whole equation by the coefficient of the degree of the variable which has degree 2. So in this case, our coefficient here is 1. So we need to divide the whole equation by this particular coefficient. As anything divided by 1 is the number itself, therefore we do not need to divide in this particular equation. So this equation can be written as it is, which is m square plus 5m plus 5 is equals to 0. Now we need to compare this equation to our standard quadratic equation, which is m square plus b by am plus c by a is equals to 0. We need to find the value of half b by a whole square, which is equals to half. The value of b by a is 5, and square here, this becomes 25 divided by 4. Now we have to add this value to both the sides. Now here we have m square plus 5m plus 5 plus 25 divided by 4 minus 25 divided by 4, or sorry, is equals to 25 divided by 4, because we are adding 25 by 4 to both the sides. So now once I get this, remember, the constant term which we did not add to both the sides has to be moved to the right hand side. So this becomes m square plus 5m plus 25 divided by 4 is equals to 25 divided by 4 minus 5. Now we need to compare this. Now as we can see, there are two plus signs here. So if we look at the formula of a plus b whole square, this is equals to a square plus b square plus 2ab. And if you look at the formula for a minus b whole square, this is equals to a square plus b square minus 2ab. As we can see, we need one here and one here. We need two plus signs, and there are two plus signs in a plus b whole square. Therefore, this will be in the form of a plus b whole square. So that means m is equals to a is equals to a square, m square is equals to a square, and this value is equals to b square. That means a is equals to m and b is equals to 5 divided by 2. You do not need to write this particular part. This particular part is for your explanation so that you understand how to get the values of a and b in order to form a complete bracket. Now, once I get this, all I have to do is I have to write m and 5 by 2 in the form of a plus b whole square. So this becomes m plus 5 divided by 2 whole square is equals to 25. Now in this case, I'm solving the right hand side simultaneously, minus 20 divided by 4. Now I have to take square root of this equation. So I'll get m plus 5 divided by 2 is equals to under root plus minus 5 divided by 4, and under root 4 is equals to 2. So here I have m plus 5 by 2 is equals to plus minus under root 5 divided by 2. And if I take this, becomes m is equals to plus under root 5 minus 5 by 2, and or you can write or m is equals to minus under root 5 minus 5 divided by 2. So you can write m is equals to under root 5 by 2 is common, bracket 1 minus under root 5, or m is equals to minus under root 5 by 2 and 1 plus under root 5. This is your solution for this particular answer. I hope all of you understood how to use completing the square method in order to solve quadratic equations. Now, before ending the section, we are going to look at how we're going to make sure that we have steps in order to understand how to solve completing the square method. So, the first step is always that you have to divide the equation by the coefficient of variable with degree 2. As we can see in the question, we divided the whole equation by this value 1 over here, by this value 1 here, and in our first question we divided by this value 5 here. This value is the coefficient of the term x square and 1 for m square respectively. Now in the second step, we determine the value of half upon half into b by a whole square after we compare this to our standard equation. Now remember, in completing the square method, our standard equation is, I'll write this in a different color so you remember this, is x square plus b by ax plus c by a is equals to 0. For completing the square method only, this is my standard equation. So in the next step, add the value half b by a whole square to both the sides. As we can see in question number 7, sub question 4, our half b by a square value was 25 by 4 and we added 25 by 4 to both the sides of the equation. Similarly, in question number 1, my half b by a value was 4 by 25 and I added 4 by 25 to both sides of the equation. Now, once I do this, I have to shift the constant value from original quadratic equation, from the original equation to the right hand side. Now here this particular term is very important, the constant value from original equation. So in 6f, this is my original equation. So now as the steps go on and as I add half b by 8 b by 2a whole square, my 5 value moves to the right hand side. As we can see in our original equation, 5 was my constant, so I need to move 5 to the right hand side. Similarly, in question number 1, example number 1, page number 38, 3 was my constant value, or rather minus 3 was my constant value, and I need to move this value from the left hand side to the right hand side. And when I made a mistake here, this is my original equation, as we have to compare our standard equation to x square plus b by a x plus c by a is equals to 0. This was my original equation, so this becomes my original constant in the original equation. So once we do this, all is left in step number 4 is to form a complete bracket on left hand side and solve the right hand side. Once I get this, in step 5, all I have to do is take a square root and in step number 6, take any constant that is on the left hand side on LHS to the RHS. This step means is that we take this particular value plus 5 by 2 to the right hand side in order to get my solution. So these are the 6 steps that are necessary. Make sure you read them once, twice before solving questions from completing the square method. Once you do this, as you keep on practicing, completing the square method will be much easier for you to solve or to use for any quadratic equation that you see. This will be all for this section. Thank you.